equations and their graphs, and we're going to learn how to do calculus on parametric equations. So what is parametric equations? First of all, when we are talking about parameter, it means that we are talking about a variable. So this is the first thing. Parameter is equivalent to a variable. Well, when we're talking about parametric equations, in general, we're introducing a new variable to the equation. So when we have an equation in x and y, when we're talking about x and y, in just simplest form possible, we are thinking about the position of a particle. Remember that x, y in the plane represents the position of a particle. Suppose you have a fly in the room moving around and you're interested in knowing what is the position of that fly in this room. So that fly might start at this point. You notice the fly at this point, and then it starts moving this way. It has a behavior, am I right? So if you connect these dots, you see a continuous graph of the behavior of the fly in this room. So it might be a nice path. It might be a quadratic path or linear path. So it might be like this, a linear path. If you connect it together, this is the behavior of the fly, or it might be a quadratic path. Okay, it's not very unusual to follow the path of a fly, follow the path of a plane in the sky, and so on. At each moment, at each time, this fly has a position, x, y. For example, you can connect y and x together, and for example, you have y equals to x squared on the positive side of x-axis. So you are the mathematician here. You should be asking this question. Well, how do I connect the position of the particle to the time? This is a legit question. I'm looking at my watch and I notice the fly at time 0. Suppose t is equal to 0 and you notice the position of your fly. It's just right here. T equal to 0. Then after 1 second, the fly is here. T is equal to 1. And it keeps going. Well, the question is, how do you connect the position of the fly, of the plane, of the particle, for example, to the time? This new variable, t, is your parameter. Rewriting the equation in terms of t gives you a parametric equation. So when we have an equation in x and y, we are interested in representing this relation in terms of another variable. Later on in multivariable calculus, you learn how to introduce 2 or more parameters and write x and y in terms of those parameters. But for elementary calculus, we're just interested in one parameter. Well, in this case, you might say, okay, I can set x equals to t and my y is equal to t squared. Why not? You can set x equals to 2t, then your y is 4t squared. You can select any variable representing the time yourself. It doesn't change the fact that you're eventually introducing a new variable. So we have different choices. One choice might be, hey, let x be equals to t and y is going to be t squared. I'm going to set my x equals to variable t, so my y is equal to t squared. You might say, hey, I want to introduce a new variable like s. Of course, why not? X is equal to s and y is equal to s squared. You might say, hey, I want to use a scalar, a number. Why not? You have many choices. This is totally up to you. Let x be equals to t divided by 2. So y is going to be t squared over 4 and many more choices. So in general, when we are talking about parametric equations, we are defining new functions. A parametric equation can be written this way. A parametric equation can be written as x equals to a function of parameter t and y a function of parameter t. This function can be linear function, quadratic function, radical function, anything that you like. Our job, our goal is to find those parameters that make the computation easier. Recall that in pre-calculus, you learn that, well, when you have polar coordinates in polar world, x is equal to r cosine theta and y is equal to r sine theta. This theta, this angle is a parameter. We are writing x in terms of theta and y in terms of theta. Theta is a variable, it's not time. What is it? It is the angle. The same thing is happening here, but we are generalizing the idea. We're introducing more parametric equations. For example, let x of t be equals to, well, let me follow the note. T squared minus 2t and y of t be t plus 1. What is it? This is a question that we are having. They have a parametric equation. Be a parametric equation, and we are interested in analyzing this parametric equation. What's the graph like? Analyze this parametric equation. Well, okay. How do we analyze this parametric equation? We have different approaches. The very first approach is to plug in different values for your t, find x and y's, plot them into xy plane, and graph it. So step 1. Graph it.
Professor, you're lagging, so it's kind of hard to follow you.
So, step 1, graph it. How do we graph this? We plug in different values for t, find x and y, and graph it. T, x, which is t squared minus 2t, y, which is t plus 1, and the ordered pair, x and y. Okay, let us plug in t equal to 0. If t as a parameter is 0, x is 0, y is 1. So at time, at angle, you name it, any parameter, the position is 0 and 1. Suppose t is equal to 1. If t is 1, then x is negative 1 and y is 2. The next point on the graph. Suppose t is negative 1. If t is negative 1, you get 1 plus 2, which is 3, and y is equal to 0. 3 and 0. So we have 3 points. Let us try to graph this guy. Okay, so we have x-axis, we have y-axis. The very first point, 0 and 1, 0 and 1. The second point, negative 1 and 2, negative 1 and 2. Then we have 3 and 0. Well, 1, 2, 3 and 0. Okay, it seems like we need more points. More points, negative 1 and 2. So let us plug in, for example, t equals to 2. If t is 2, we get 4 minus 4, which is 0. And here y is equal to 3. So 0 and 3. I see a pattern. So if I plug in t equals to 3, I should get a point, which is here. So if you plug in 3, you get 9 minus 6, which is 3, and 4. 3 and 4. Okay, very well. It seems like my graph behaves like this. So this set represents this graph. Okay. Step 2, write this guy in terms of x and y, get rid of t. Step 2, eliminate t. How do we eliminate t? Take a look at your second equation. Y is t plus 1, so t is y minus 1. Substitute in the first equation in x equals to t squared minus 2t. Wherever you see t, write down y minus 1. So my x is equal to y minus 1 squared minus 2 times y minus 1. This equation has no t in it. By using Desmos, you can graph this equation, and this is the graph of the equation that has no t in it. You can also go backward, set t equals to y minus 1, and x is t squared minus 2t. going back and forth between parametric equations and equation in X and Y. Very well. So let us compare these two examples. What's the difference between these two parametric equations? Example part A. Your X is cosine t, your Y is sine t, and t is bounded between 0 and 2 pi. And the second one is, well, X is cosine 2t, Y is sine 2t, and then t is bounded between 0 and 2 pi. Very well. So let us do the first step, try to graph what's going on. Then we eliminate t, trying to write these equations in terms of just X and Y. Okay, step 1, graph. We can plug in different values for t, and then find X, find Y, and the point xy. So t starts from 0. When t is equal to 0, your X is 1, your Y is 0. So 1 and 0 is the starting point of the movement of this particle. Well, t might be equals to pi over, for example, 4. In that case, your X is square root of 2 divided by 2, Y the same. It can be pi over 2, 0 and 1. You're going back to pre-calc. It might be like pi. Then in this case, we get negative 1 and 0. And at the end, the terminal value is 2 pi. You get 0 and 1. Okay. So let's see what's the behavior of this particle. 1 and 0. This is the starting point. Then it goes to square root of 2 divided by 2, and then 0 and 1, and then it's just going back to the original point. So if you plug in more points, you see you have a unit circle. Unit circle. Okay. In step 2, get rid of t by going back to pre-calc. We know that if we square both sides, x squared is cosine squared t. Y squared is sine squared t. So if you add this together, you get x squared plus y squared equals to 1. You can verify that the graph represents a unit circle. What about this guy? What's the difference between A and B? Okay, let's see. First, graph it, step 1. Graph, well, here I have my t, x, y, the position x and y. T is equal to 0. T is equal to 0, and my x is equal to 1, my y is 0, 1 and 0. This is the starting point, which is similar to previous one before. If I plug in pi over 4, what do I have? I have cosine of pi over 2, which is 0, and sine of pi over 2, which is 1. 0 and 1. Instead of being halfway here, this guy is at 0 and 1. If I plug in, for example, pi over 2 here, what I get cosine of pi, which is negative 1, and sine of pi, which is 0, negative 1 and 0. Okay, it seems like this particle is moving faster than that particle. If I plug in, for example, let's see, pi, I get 2 pi, which is 1, and I get 2 pi, which is 0, 1 and 0. So at pi, you already have 1 full rotation. If I plug in, for example, let's see, 2 pi, what do I get? I get 4 pi, which is 1, and then 4 pi, which is 0, 1 and 0. It means that we have to plug in more values in between. Plug in more values to see the behavior, and then finally plug in 2 pi, 1 and 0. So let's take a look at the graph. This is your particle. Start 1 and 0, which is here. Then it has a complete rotation when t is equal to pi. So it's going here when t is equal to pi. And then it starts rotating one more time. T equals to 2 pi. So that's the difference between these two parametric equations. This guy has only one full rotation, but your fly, your plane, whatever it is, has rotated twice. 2t, 2t. That's the difference between these two. But if you convert this in step 2 to x and y, what do you see? Is that x squared is equal to cosine squared 2t, y squared is equal to sine squared 2t. If you add this together, x squared plus y squared is again 1. So if you write these two this way, you don't see the behavior as the rotating behavior for these two particles. Well, now that we talked about parametric equations, we are interested in finding the derivatives. Well, how do we analyze the rate of change of these types of equations? Well, since you have a parameter, you have to calculate the rate of change in terms of that parameter. So, to find the rate of change, of a parametric equation, we have two options. Option 1 is to get rid of t. Eliminate t and take the derivative using the techniques that we learned before. In this class. Option 2, if it's complicated, if you cannot get rid of t, sometimes you have complicated parametric equations. You move to option 2. The second option is, well, you take the derivative of x with respect to t, you take the derivative of y with respect to t. Take the derivative of x with respect to t and y with respect to t. For example, let's take a look at the note. let x be equals to t squared and y be t cubed minus 3t. Find the equation of tangent line at 3 and 0. So I'm going to write down the solution on this side. To find the equation of tangent line y equals mx plus b, we need to find the slope. Well, to find the slope, we need to find the derivative of this, whatever equation is. So we need to find the derivative. To find the derivative, see if you can get rid of your t. Well, by looking at t here, x is equal to t squared, so t is equal to plus minus square root of x, and y is plus minus square root of x to the third power minus 3 plus minus square root of x. Well, it seems like we have a lot of square root, we have a lot of things to deal with. I'm not feeling very comfortable using the option 1, getting rid of t. So what I'm going to do, I'm going to take the derivative of x with respect to t, take the derivative of y with respect to t. So dy over dx is equal to dy with respect to t divided by dx with respect to t. That's how I can find the rate of change of y with respect to x. So the derivative of y with respect to t is 3t squared minus 3 divided by the derivative of x with respect to t is 2t. This is what I have as the rate of change formula, rate of change of y with respect to x. But it's written in terms of t. How do I find the slope? We know slope is a number. It's not a function. What do we have in this question? In this question, we know that we want to find the tangent line at this point, 3 and 0. 3 is our x and 0 is our y. 3 is x, y is 0. How do I find t? I need to plug t in to find m. We need to find t to evaluate m. We know x is t squared. X is given to us as 3. 3 is equal to t squared. So t is equal to square root of 3 and t is equal to negative square root of 3. At the same time, y is given as t cubed minus 3t. So since y is equal to 0, 0 is t cubed minus 3t. What's the meaning of that? It means that t parentheses t squared minus 3 is equal to 0. So it means that t is 0 and t is plus minus square root of 3. How many values I found? I found 3 values for my t, 3 possible values. Does it mean that I have 3 slopes? We have to check. Now plug this into the rate of change. If t is equal to 0, then you get -3 divided by 0. We don't need t equal to 0. What if t is equal to square root of 3? When t is equal to square root of 3, m is equal to 3 times 3 minus 3 divided by 2 times square root of 3. It gives me 6 over 2 times square root of 3. When t is equal to negative square root of 3, your slope is equal to 3 times 3 minus 3 over -2 square root of 3. -6 divided by 2 square root of 3. We found 2 slopes. That's because of the graph of these parametric equations. We have 2 slopes. We can simplify this. 2 slopes. Now that you have your slopes, you can write the equation of the tangent line. Tangent line for the first slope and tangent line for the second slope. Well, let us take a look at the graph of these parametric equations. As you can see, the graph behaves like this, and you have 2 tangent lines. At 3 and 0, these are the tangent lines that we have. By using decimals, the first parameter t squared and the second parameter for this parametric equations t cubed minus 3t, and this is the behavior of this graph. So here you get 2 tangent lines at 3 and 0. So the graph has this behavior. That's why you have 2 equations for the tangent lines. So I expect you to ask, now that you took the first derivative this way, what is the second derivative? So we are doing calculus on parametric equations. So a parametric equation is written as x f of t and y g of t, and we learned about the first derivative first.
Sir, you're lagging again.
Parametric equation, x is f of t, y is g of t. First derivative dy over dx is dy over dt divided by dx over dt. Now the second derivative. Second derivative is defined as, well, the second derivative of y with respect to x, which is the derivative with respect to t of the first derivative divided by the derivative of x with respect to t. So whatever you found in the first derivative, you have to take the derivative with respect to t of that and divide it by the derivative of x with respect to t. Let us go back to our previous example. Our x was t squared and y was t cubed minus 3t. The first derivative was equal to 3t squared minus 3 divided by 2t. The second derivative is equal to, we are taking the derivative of this quantity with respect to t and divide it by the derivative of x with respect to t. So here you have d dt, the derivative is an operator of 3t squared minus 3 divided by 2t over the derivative of x with respect to t, which is 2t. Okay. On the numerator, we have to apply the quotient rule. So the second derivative is equal to, the derivative is 6t times 2t minus 2 times 3t squared minus 3 divided by 2t squared, and here you get 2t. The rest is algebra, simplifying the whole thing. It's equal to 12t squared minus 6t squared plus 6 divided by 8t cubed. So we get 6t squared plus 6 divided by 8t cubed. We can cancel out 2, 3t squared plus 3 divided by 4t cubed. This is the second derivative of this parametric equation.